Good morning, students. In the last class, we have studied regarding a physical change and a chemical change. Physical change and a chemical change. Okay. Now, just we will recall what we have studied under physical and a chemical change. In physical change, we said that it's a reversible process. Okay, it's a reversible process, and we said it is a temporary process. Okay, we have taken an example of ice cube, and we said if there is a change in state, size, and shape, such changes all comes under physical change. Next, we have studied a chemical change is an irreversible change. That means it cannot be come back. Whatever products are formed after the chemical reaction has undergone, you won't get, taking the products again, you won't get the reactants. Hence, such changes we call them as an irreversible process or irreversible reactions. Next, we said chemical changes are permanent changes. Okay, like rust formation, forming a rust on an iron nail. What we have done, an iron nail is kept for some days outside your home. Then iron nail easily reacts with whatever air and water present in the atmosphere and forms a rust there. We called Fe, where iron symbol is Fe. It is reacting with oxygen and forming FeO. FeO is nothing but your rust, that is ferric oxide. See, these are the some of the differences we have studied under physical change and a chemical change. And also we said that chemical changes are also known as chemical reactions. Okay, chemical changes also comes under chemical reactions. Now here, let us say, take our simple example. What is H2? It's a hydrogen. Now, when hydrogen is reacting with oxygen, it is giving H2O. Okay, children? Any chemical reaction to the left side of the arrow, we always call them as reactants. Left side of the arrow, we always call them as reactants. To the right side of the arrow, we always call them as products. Okay? In any chemical reaction, to the left side of the arrow, we call them as reactants. To the right side of the arrow, we call them as products. Okay. Here, there may be any number of reactants, and also you may get a single product or more than a single product. Always it is not necessary that to get only a single product. You can get so many products also. Look at here, Zn plus HCl gives ZnCl2 plus H2. In this reaction, Zn and HCl are called as reactants. ZnCl2 plus H2 are called as products. Okay, these are the some of the important terms in case of your chemical reaction. In any chemical reaction, there must be a reactants and a products. Not only this, you have another one called as, let us say another example, CaO plus H2O gives CaOH taken twice plus delta H. Look at here. Here CaO, what does it indicate? Calcium oxide. When it is reacting with water, it is giving calcium hydroxide plus delta H. See, in your product side, products, are these are products or not? To the right hand side of the arrow, I call them as products. To the left side, we call them as reactants. Delta H in chemistry always represents heat energy. See here, in any chemical reaction, you will be seeing either heat is liberated, that means heat is coming out, or in some reactions heat is absorbed. Okay, liberated, heat is coming out means such reactions we call them as exothermic reactions. Okay, there are two types of reactions. In one reaction, heat is coming out, or we call heat is liberated. Such reactions are called exothermic reactions. In some reactions, heat is absorbed. Heat is absorbed. Such reactions are endothermic reactions. Okay? Two types of reactions. Heat is liberated. It's an exothermic reaction. Heat is absorbed. It is an endothermic reaction. Now here in the exam, they may give you a chemical reaction and ask you to find out, is it an exothermic reaction or an endothermic reaction. See here, always if the heat energy is indicated with plus on the product side, such reactions are exothermic reactions. Product side lo plus and heat energy pedite ఆ reactions అన్ని exothermic reactions. Those reactions in which the heat energy is represented with the plus on the product side, those reactions are exothermic reactions. Now, what is how to find out an endothermic reaction? Look at here. CaCO3 upon plus delta H gives CaO plus CO2. For your understanding sake, I have taken one example. CaCO3 plus delta H gives CaO plus CO2. Here On which side your heat energy is there? On the reactant side. Look at these two equations, children. In the first equation, heat energy is on the product side. Such reactions are exothermic reactions. Now, here heat energy is on the reactant side. Such reactions are endothermic reactions. See, sometimes they may also give you CaCO3 gives CaO plus CO2 minus delta H. Which type of a reaction now? It's an endothermic reaction. That's why I have told you a positive sign with delta H. See, sometimes they may give you plus delta H equal to 512 kilocalories. You need to see this sign. Plus delta H means it's an exothermic reaction. Now here he has taken minus delta H to the product side. Minus delta H to the product side. Hence, this is an endothermic reaction. Nothing he has done. Here it is plus delta H. This plus delta H, similar to your mathematics. If you take it to the other side, minus delta H. Okay? Either in the reactant side, if they give you plus delta H, it's an endothermic reaction. If they give you minus delta H on the product side, it is also an endothermic reaction. See, in your textbook page number 28, he has given C plus O2 gives CO2 plus Q. I have given delta H plus Q is also heat energy. Plus Q on the product side indicates which reaction? It's an exothermic reaction. Look at the second equation. N plus O2 gives 2NO minus Q. Minus Q, heat energy, is on the product side. Hence, it is an endothermic reaction. Okay, children. Now, we will do one activity based on your chemical reaction or chemical change. Okay. See, the same activity is there. Activity 3 in your textbook. In the second chapter, the same activity is there in your third chapter, acids and bases. Okay? Let us see this activity. Activity is, we are doing this activity. What happens when zinc reacts with hydrochloric acid? That means, is it a chemical change or any physical change? We need to find out. Okay? For this, in the next chapter, the same activity, write an activity to show that acid or acids reacts with metals. Acids reacts with metals to give hydrogen gas. Okay. Now for this, the materials required are a conical flask. You have seen in the lab. A conical flask is required. zinc granules, means small pieces of zinc. Okay. Next, HCl. What do you mean by HCl? Hydrochloric acid. A burning matchstick. Okay. Zinc granules, hydrochloric acid, a conical flask, and a burning matchstick. See here, in the 9th class, I have told you how to test if the gas evolved is a hydrogen gas. If you not only a burning matchstick, you can take a candle also. If you place near the hydrogen gas the burning candle or a matchstick, it will put off or gives a pop sound. Okay. Now, procedure. Procedure is, first, in a conical flask, take some zinc granules, small pieces of zinc granules. Okay, zinc granules you need to take in the conical flask. Now here add some amount of hydrochloric acid. These zinc granules reacts with hydrochloric acid. If you want, you can close the mouth of the conical flask with a stopper or a cork with a single holed rubber cork, and to this, from this hole, you can send a delivery tube, so that why we are closing the mouth of the flask, whatever reaction with the zinc and hydrochloric acid, a reaction will be undergone and some gases will be coming out. These gases, if we won't close the mouth, they can easily escape into the air. Hence, I have closed the mouth of the flask with a single holed rubber cork. Through this single hole, I am passing my delivery tube. The other end of the delivery tube, you place it in a soap water. Okay, the other end you are placing it in a soap water. Now here, the zinc granules, after reacting with hydrochloric acid, whatever gas is liberating, it comes out through the delivery tube. Now what you need to do, take a burning matchstick and place it near the other end of where the hydrogen gas is coming out from the delivery tube. Then this matchstick will give you a pop sound. Okay, what we have taken in the conical flask, zinc granules, and we have added HCl, hydrochloric acid, and to the from the single holed rubber cork we have passed the delivery tube. Now the gas will enter into the delivery tube and this is placed in a soap water, and through the other end we are testing which gas have been coming out or evolved, and I have taken a burning candle or a matchstick and it is giving a pop sound. Whenever it gives a pop sound, that gas we call it as a hydrogen gas. Here the reaction is Zn plus HCl gives ZnCl2 plus H2. See here, I have kept an arrow besides H2. What does it indicate? Hydrogen gas is liberated out. Okay, for gases, always we will keep an arrow upwards. For precipitates, we call PPT or otherwise, we always keep an arrow downwards. Okay, precipitate means some substance is formed which will not be dissolved in a water or any liquid. Such things we call them as a precipitates. For always the precipitates, the arrow should be kept by showing downwards. For gases, we will show by showing the arrow pointing upwards. Okay. See here, we need to find whether this reaction is it a chemical change or a physical change. First I have taken zinc and I have reacted it with hydrochloric acid. I am getting a new product called zinc chloride and hydrogen gas. This is a permanent reaction. Again, by taking zinc chloride and hydrogen gas, you can't get zinc granules and hydrochloric acid. Hence, this is comes under a chemical change. Okay, children? Note down your homework today. First question. What is an exothermic reaction? And an endothermic reaction? Second question. Write an activity to show that acids, when reacted with metals, liberate hydrogen gas. Okay, children? Thank you.